So you had to match up the graph to the inverse. A good place to start is pick a point and interchange it and see if that helps you get there. So 15 was C, 16 was B, 17 A, and if you want to, like kind of imagine your line here, your y equals x line. Take this point, put it here, you'd kind of see that one go like that. And this one, the cubic function, always goes the opposite way, like your tangent function. Remember doing your tangent inverse? Your tangent had the natural asymptotes there, and then it went this way. Did you do a tangent inverse? Okay. Okay. It's a good thing we didn't go. Well, we were going to take some stuff out of the precalc, but it's a good thing we didn't. Okay. All right. Then you had to take these, and you had to prove that they were inverses of each other. Graphing is a nice visual way, and you can look at the table and see if the points are interchanged. But algebraically, this is algebraically. You have to do f of g and g of f. And when you interchange them, they will both be equal to x. So technically, y equals x. That's your reflection line. This one too, this restricted your domain. And it should make a little bit more sense after yesterday's. This is just one little arm over here and move 4 to the right. When I do this, this is a parabola that goes like this. But again, we don't want this part. We only want from here on. That's why they restricted this part. So it should make a little bit more sense after yesterday. Make sure that they equal to x. As bad as these look, when you plug them back into the fractions, they do reduce down nicely. Any questions? Are you still trying to remember what we did that day? No? Okay. Give you guys a minute. Can you see okay up there?
Can you move it down a little?
Yep. Here? Down further? Understand? Okay, just watch your fractions. When you plug them in, this, you're going to distribute this, so this is going to knock this fraction out. That negative 6 is going to knock this 6 out. Then you're left with 7. 7x, negative 7x over negative 7, that's going to come out. They kind of work out nicely when you plug them back in. Questions? The last part, I think you just had to state if it was 1-to-1 or not 1-to-1. 1-to-1 means it can pass a vertical line test and a horizontal line test. So if it is 1-to-1, we know when we do the inverse, God bless you, it is a true inverse. If it's not 1-to-1, it just remains a reflection over the line y equals x. Yes. On the f of g. Why did I cross out the 2? Okay, let me see. I factored out the 2 out of here. I factored out a 2. 2x plus 6, I could factor out a 2, and then cross out the 2. Because you're left with this. 2x plus 6 over 2. Either way you want to do this, you can go like this, and makes it x plus 3, or you can factor out a 2. I tend to factor. But this is okay too. So make sure you know that it's 1-to-1. Graph them. Graphing it is a very good way to tell because you can pass, if it doesn't pass a horizontal line test, then it is not a 1-to-1.
Wait, can you go back up?
Go back up. Sorry.
Understand how you got 45.
A 1-to-1. This is the equation of a line.
Oh.
So technically it looks like this. So it's a line that crosses through the positive 3, a little bit of a negative slope, and it passes a vertical and a horizontal line test. This one, even though it doesn't have a restriction in the denominator, this breaks this off, and this does not pass a horizontal line test. And again, put them in your couch. Do a visual on those guys. These also, a lot of you are still struggling with the domain for this. This is really, really important, this domain, when it's a quadratic. I noticed it on your test. When it's a quadratic, you still set this, whatever it is, greater than or equal to 0. However, it's a quadratic, yes.
When are we gonna get our test back?
I just graded I'm grading the last one. Got one last one made it up, and I think everybody else has. Ashley has it too? Let me just check. I think everybody has it now. So probably tomorrow. How's that? I gave you your grades.
Yeah.
Yeah, I can even give it back to you at the end of today if you want. Remind me. Okay, so again, this is extremely important. Not as important as your test apparently, but very, very important. When you do this, you are going to set this equal to 0 to find your roots. And x is going to be equal to plus or minus 4. Then you have to build your number line. If it's not in a denominator, then you can use this. So it's filled in. Your parabola is opening which way? Down. So figure your quadratic going like this. Or plug this piece into your y1 and test to the left of -4, in between -4 to 4, to the right of +4. You want to know where the value of that y is positive. This part, this value is negative. This part, this is positive. You want the positives. You want in here. So your domain is from -4 to +4. And again, this doesn't pass a horizontal line. A y equals 10 is a vertical line, so that doesn't pass as a horizontal line, but it doesn't pass, it's when you take its inverse, it will be a vertical, so it doesn't become a function of 1 to 1. These guys, you still have to say 1 to 1. Cubing 1 to 1, this, graph it, this throws you off, not a 1 to 1. Oh, you didn't have those? Okay. Did you have 71? And you got lucky because the last one didn't print out, and I was going to write it in, and I didn't write it in. I don't know why it didn't print out, but it's kind of similar to the other one. You okay with these guys? Finding the inverse equations? Interchange the x and the y, solve for the y. And this is important, guys. Make sure you use your inverse notation. When it is a true inverse, if it is not a true inverse, we're going to restrict it. But if it is not overall and we didn't have to restrict it, then you don't use the f to the -1. But we will, and we will restrict it. Good? All right, again, I apologize for not doing that one. Okay, so the first two I had you restrict to the positive. The second two I had you restrict to the negative. All right, let me come around and check this homework while you're checking. And then we should be caught up.
When you take that out absolute value, wouldn't it make it plus
If you're doing your absolute value equals something, equals whatever it's going to be equal to. If you're setting this equal, you always have two paths, a positive and a negative. You always negate this part. So when you're negating this part, if this is where your x is, you interchange these. Keep this positive. Let me change that to a y. You're going to say positive x, negative x. That's the part you change. If you change inside and don't change the outside, then you have to change both of those. So if you're going to make that a positive 6, you're going to make this a negative 4y, only on the decreasing part. Make sense? Is that what you asked me? Yeah, kind of? Okay. All right. Interchange, take it out. Make sure, first of all, follow your rules. Interchange, make sure you isolate your absolute value. Then set it to the positive path. If you find this is difficult to work with, because we always put it on this side, just reflect it. Reflect it. I usually reflect it because everybody's used to doing this. Reflect this, take this out, and set it equal to the positive. If we were doing the decreasing sign, we would set it equal to the negative. Your absolute value has two paths. We'll catch you all back up. Want me to move it up a little? Okay. So everybody's good with this one. Questions? No? Don't forget to restrict that domain, because that's going to give you a line. So don't forget to restrict this domain. Again, you have an increasing portion. You guys good down there? Because it is the increasing, but yeah, yeah. Because if it was the decreasing, we would have to put a negative on. Some of them take turns. Okay, so how does this one look? This one was pretty simple, except when you get to here. Don't forget, whoa, I'm sorry. Don't forget to restrict your domain. Okay. All right. These two guys, decreasing. Your original domain and your original range, always find those and then interchange them. So you don't really have to think about your inverse. You just have to say this x value is going to become a y. So therefore, it's going to become my range. This y value is going to become an x, and this is going to become my domain. Find your original ones and just interchange them. That's your rule. Your rule for a reflection over the y equals x is always interchange the x and the y's. And it applies to domain and range. Yes? Yes. Did it say like e to the something?
I wasn't sure how to find the point, so I just put it as minimum because I wasn't sure if it touched the.
A minimum is hard on that one. You could do like the second calc value, if you can find where you intersect, you can do like the 5 divided by 2. Do you guys know how to set this? Like set it equal to 0, kind of. Because there's your shift, but it's over 2. So it's moving to the right, but then it's over 2. Use that fraction.
I wasn't sure if it touched the line, that's why I didn't use
You
intersect.
do the intersect. Well, yeah, but you can also do, oh yeah, you couldn't find the 5 halves. Is that what you couldn't find? Did you find the 5 halves first?
I got a decimal for that too. I got like 2.5.
Oh, weird one. 2.5? That's the same as 5 halves. That's okay. Yeah.
I got a jumping number.
So but once you do that on your calculator, that I find easier. For me, I always find it easier. Go second calc value, and just put in 2.5, and it'll give you your y. This is not the right graph. Just do second calc value, put in 2.5, and it'll return your y. It's just easier than doing a minimum or maximum or intersect. Yeah. I find that easier. Get used to that second calc value. That's a nice thing. You can always check your roots like that too, even when they're irrational. Okay. All right, stay with me, guys. These are your decreasing parts. Oh, I was just working so good with this. All right, here we are on the decreasing side. We take the square root. After you interchange it, when you take the square root, don't forget your square root gives you a plus or minus. So we want the negative part. And this will kind of take care of itself on this one. But again, give me the domain and the range for the inverse. This is the important part. When you take the square root, don't forget the positive negative. Okay. Everybody good with this part? Yep, okay. And when you graph this, graph your y equals x. It really kind of makes it better visual. Also, when you're doing these guys, sometimes a zoom 5 works better. A zoom 5 is a square, and it takes that distortion out, so you actually can see a better reflection. Sometimes it looks a little distorted, and you say, well, is it really a true reflection? Do a zoom 5, they look a little bit better. Okay, then the last one. Hopefully I can get through the last one. That's also decreasing. A fourth root works the same as a square root. When you take the fourth root of something, you still get a plus and a minus. But now instead of a square root, you just have a fourth root. Your goal is to find where this key point is right here. And interchange that. That kind of tells you what direction you're going in. You went 2 to the right, and you went up 3. Use your transformations. 2 to the right, up 3. There's where it starts. And then do a calc value and find where your y is. Actually, you can figure that one out too, great. Interchange it and get your inverse. Everybody's good with this? You can finish copying that. Let me just hand out today's work while you're copying. It gives us a basic equation, standard form. Standard form of a quadratic. This is your standard form, ax squared plus bx plus c. You guys are used to this. This is your vertex form. And I wrote down your vertex form for you. This is really important. A tells us the same as this A, tells us if your parabola is opening up if it's positive, opens down if it's negative. If it's a y squared one, then it's going to open to the right when it's positive, to the left when it's negative. HK is your vertex. So, for instance, if your parabola opens here and it goes over here to 4, 2, this is the H, this is the K. Your axis of symmetry cuts down here and it cuts through your X1. So therefore it's going to be an X equals line. And which one represents the X? The H. So that's why your axis of symmetry is X equals H. Your roots of the parabola, this one didn't have any real roots, so if your roots come through here, your roots are on the x-axis, your real roots, your real zeros, and we're just going to work with real ones for now, is when y is equal to 0. And that's the part that works out so nice for this, because when you plug a y equals of 0 in, you have a nice equation to solve. You don't have to factor, you don't have to do the quadratic formula, you use this. Excuse me. Shake this stuff. Alright, so we're going to start with something very, very basic. We're going to start with this guy. Now, because we want to get to this format, alright? I'm sorry? You don't have that. You're going to put that in there. You didn't have any of this on there. So this is like the note part. I wanted to do a simple one first before I got into a tougher one. This way, it makes a little bit more sense. So we're going to start with this guy. All right. Now, can this be factored? No. Did you guys set this to 0 and move the 7 to the other side? Or did you do it all on one side?
We moved the 7 to the other side.
You moved the 7. All right. So let's move the 7 first off the bat. I'm just going to reflect this because I like working this the other way. We're going to leave a space to complete the square. Is this how you did it?
Yeah.
Okay. We're just going to move it back, but once we do this, as long as you keep with what you understand, you'll understand when I do it on one side. So to complete the square, you make sure that this A is 1, right? Did you do it when A wasn't 1? You had to factor it out. You had to factor it out. So we start with a simple one. So this is your B term. You take half of your B. What is half of negative 4? So start like this. X minus 2. This is your square part. Then just go like this. What is 2 squared? Even negative 2 squared, they will always be positive. So if you add 4 to this side, you add 4 to this side. Right? Okay, so we're left with x minus 2 squared equals negative 3. Now, for us to get this in vertex form, we have to move the 3 back over. So x minus 2 squared plus 3. And this is our vertex form. So, if you will, could I take this? Could I leave a space for this? Could I do this all on one side? Oh, okay, just hang on with me. This is all 1, right? What part of the square are you going to complete? Just this, right? So you're going to add something to that square. Now, it's an equation. If you add something, what else do you have to do to it? Subtract it. So then when I come here, can I subtract the same thing? Okay, so This just allows me to leave it on one side. Process is the same. Half of this guy. And you can certainly do it like that. We can do it like that. 2 squared is 4. If I add 4 to one side, I would usually subtract 4. I would add 4 to the other side. But since I'm on one side, if I add, I have to subtract it. I have to get rid of that 4. I can't just randomly add it, right? And then this works out to be plus 3. You just end up on one side. And I'm okay if you want to move it to the other side and then just move it back later. That's fine. This actually, when you're here, when you're to this one, this actually helps you find your roots. Because this says take the square root and solve for x. That's your zeros, right? But, well, this is imaginary, so we won't worry about that. But you can either do one side or you can do 2 sides. I don't have a problem with which way you're comfortable doing this. I ask you to try the one side. It sets it up a little faster, but that's okay. Are we okay with this one? All right. Now we're going to move on to a little tougher one. This is what you guys have. All right. You want me to move the 7 to the other side?
Yes.
Okay. We'll do it both ways. We'll start with this the 7 on the opposite side. Is that good? I subtracted 7 from got it to the other side. I just flipped it around because it's easier to do it this way. Now, I need to find half of this, but this is not 1. So I'm just going to make this. I have to make this be 1. So what can I factor out of a 2 to make it be 1? 2. Just this side. I have to factor out of here all my x's. And I'm going to leave a little space to complete my square. And again, if I add to this side, I have to add to this side. Good so far? So what's half of 4? 2. What's 2 squared? Now, this 2 comes down here. This little 4 is trapped in this parentheses. Because it's really not x squared. Isn't it really 2x squared? So it's really not 4. What is it? 8. So I have to distribute this and then add it to that side. Because it's trapped inside that parentheses. I have to get it out. Oh, you do remember it?
Yeah.
Oh, okay.
Because I was messed up and never moved it.
Oh, you forgot to distribute it. So this, I'm sorry. So this is equal to 1. Now, just get it to one side. So here's the equation of our parabola. Can I just take a minute and do it on one side? Okay. Once you see, it's really not that different. Again, if you leave it on one side, guys, watch. This is the part you care about, your x's, not the 7. So look where your x's are. Factor this out to get this a 1. Complete the square right there. If you add something, you have to subtract something. And still a y equals. It still works the same. Half of 4 is 2.
If it's on one side, would you have to divide this by 2?
No. All I'm doing is factoring out of this group. Leave the 7 alone. Just work with the x's because that's the part you want to complete the square. So if I did that, and I just did this, did I change my equation at all? If I just factor it out of the x's up to here? I still am 2x squared plus 8x plus 7, right? Am I still the same? So I'm allowed to do that, right? Okay. I certainly don't want to pull it out of this because then it stays inside this parentheses and it's not pretty. So now, Still the same process. What is 2 squared? 4. So to get it out of here, first I distribute it, and then I put it over here. There's my -1. So you're still only dealing with the x's. Leave the constant one alone. And then at the end, you bring them all back together. Try a couple, do it on the other side, and try a couple on one side. What's the vertex of this guy? -2, right? It comes out the opposite way. Which way does your transformation go? To the left. -2, -1. Does it open up or down? It opens up because this is a 2, it's positive. So now we're going to find your zeros. Watch. When your zeros, so far we know this. At the -2, -1, it's opening up somewhere. I need to figure out where does it cross that x-axis. So those are my roots, or my zeros, right? So I plug in a 0 for y. And I solve. So I add 1. I divide by 2. I take the square root. Square root says plus or minus. And I subtract my 2. So my roots are these. Those are my roots. If I tried to factor this, would you be able to factor that? You'd have to use your quadratic equation, right? 2 times 7 is what? 14. Do I have factors of 14 that add up to 8? So I can't factor that, right? So you would use your quadratic equation. However, you went through all this work to find out where your vertex is, where you're going to cross wherever. We could even figure out where we cross the y-axis here. If you plug a 0 in here, a 0 here says 2 squared times, so 2 squared is 4, times 2 is 8, -1 is 7, so I know I'm crossing at the 7. I know where I'm crossing. And now I can find where I cross the x-axis as well. So the square root of 1/2 is kind of small. So -2 still puts me on this side of it. So I know I'm narrow. And what also made my parabola narrow? What made my parabola not so wide? It got narrow. The 2. Isn't this a vertical stretch? So doesn't that have that effect on my parabola? So from this guy, look how much we can tell. We can tell a whole heck of a lot from this. We can find where our vertex is. We can find where we cross the y-axis, where we cross the x-axis. Does it open up? And we can obviously see that the 2 has that effect on that. Right? Because remember, we're sketching. I'm not upset if you go the opposite way. Just try some of these. I know I didn't get to the... On the homework, let's do this.